Each of these problems, problems 3 to 6, are factoring problems. So, factor the expression. And so the factoring process, we're not looking for zeros. This is not solve, this is factoring. So let's remember kind of a algorithm that works for us. We look for factors of 30 in this first problem that add up to be negative 11. So negative 11 is our sum of the two factors. Let's see, so it's going to be two negatives because we have a positive result, but our sum is negative. So negative, let's see, 6 and negative 5 kind of pops out at us. And so when we do this factoring process, we're always going to bring down the x, or 1x, into both of these factors. And our constants here are minus 6 and minus 5. You can check that a little bit. X times x is x squared, minus 5x minus 6x. Combine those, we get negative 11x, multiply negative 6, negative 5. So this is our answer. It's a factored expression now. Turn that around a little bit, but that's all right. Doesn't matter the order. Multiplication is commutative. So we look over at this one. Now there is a factor pattern. This is called a difference of squares, but you can also use this process. Negative 64 is our product. 0 is the sum. There is no middle term, no end term in this case, no b term. So factors of 64 that add to be 0 must be opposites. 64 is 8 times 8, so we could have negative 8 and positive 8. So we bring down the n into both our factors, and they're n plus 8 and minus 8. It is a difference of squares, and when you see this without the middle term, you can assume that you just do the square root of this constant term. Even though it's negative, just take the square root of 64, and it's plus or minus 8. N minus 8, n plus 8. Okay, so we'll do the same thing here. Now this problem, when we go to factor, we are going to bring the 9x into both of these factors. And what we're looking for as our product is 9 times 25. That's 225. And the sum is 30. Now there's something special about this. This is actually called a perfect square trinomial. 9x squared is 9 is a perfect square, 25 is a perfect square. There is a process to doing this, but let's do it the old-fashioned way and just say, what are the factors of 15 that add to be 30? Bit of thought, you might come up with, well, 225 is 15 squared. So that is it's the same in both cases, plus 15 plus 15, oops, 15. Now, the process here, when we have to bring a number down into the factors that is not 1x, then we're going to have to look for common factors that we can, greatest common factor we can factor out of these two numbers. most all students see that 3 factors out, both those. So really our final answer, this doesn't work. 9x times 9x is not 9x squared, it's 81x squared. So we know we have to do some factoring out. 3 into 9x is 3x. 3 into 15 is 5. And we see the same thing on our other factor, so it's 3x plus 5. And this really is just a square, 3x plus 5 squared. That's our answer. Now you could also, if you note that this is a perfect square, this is a perfect square, and the square root of 3x, you can kind of ask yourself, let's change color here a little bit. The square root of 9x squared is 3x. And the square root of 25 is 5. And then perfect squares, when you square these, notice if I take 3x times 5, I get 15x. And if I double it, I get 30. That's how you recognize the factoring pattern for a perfect square trinomial. But you do have to note, that's perfect square, this is perfect square. Then you should check for, is the middle term double the product of these two square roots? Anyway, there's that that answer. And then let's come over here. Let's try a different color. Over here, same thing. We have a product of 2 times negative 15 or negative 30. Our sum is 7. We know we have a positive and a negative because our sum is positive, our product is negative. 30 and 3, so it would be positive, 10 and 3 would be positive 10 and negative 3. So as we set this up, bring down the 2s into both of these, bring these two factors of negative 30 into our binomial, plus 10, minus 3. And then we have to ask ourselves, now again, 2 times 2s times 2s is not 4s, so we know we need to do some factoring out here. And 2 and 10 have a common factor of 2. So this is s plus 2 into 10 is 5. 2 and 3 don't have a common factor, 2s minus 3. And then we should just check. S times 2s is 2s squared, yes. S times minus 3, negative 3s. Here we have 10s, negative 3 plus 10 is plus 7, and negative 15. So we've got our answer, s plus 5 and 2s minus 3.